Hi everybody, welcome to Physics 2. Let's go ahead and get started with our first module, which is on fluids. Some of these concepts should be familiar. We'll still be dealing with force. Remember Newton's second law, force equals mass times acceleration. We're also going to be dealing with density, area, and pressure, so some new topics to go ahead and get started. So, let's take a look. First thing we want to know is what's a fluid? Well, fluids are substances that easily flow. There are three states of matter that are generally considered fluids: the gases, liquids, and plasmas. Plasmas are uncommon on Earth, but they do make up most of the solar system, like stars. So the sun is actually plasma, and it's neat because it's a fluid. It's not a solid, rigid body. Like when our planet Earth spins on its axis, the equator and the poles all spin one revolution per day. The sun's not like that. Since it's a plasma body, it's a fluid body, the equator and the poles don't spin at the same rate. So different parts of the sun are moving different revolutions in the same amount of time, which is sort of cool. Gases and liquids are more manageable for us. We have those in abundance on Earth, and we will be looking at pressures and forces that act on fluids and liquids. Okay? One of the things we have to be able to do when we're talking about how fluids behave is talk about density. Remember, you guys should know density is the ratio of mass to volume. Mass is generally measured in kilograms, and volume is generally measured in cubic meters, or at least that's the SI base unit for this stuff. We're going to look at grams per cubic centimeter here in a minute. This symbol here is rho. It's a Greek letter. It's called rho. It's not a lowercase p. And that's the symbol for density. And we're going to use this a lot, so be familiar with that symbol. You should know rho. You should think, oh, that's density. That's mass over volume. Now, one of the things that people talk about when they talk about density is they talk about how heavy something is. Like, we think of iron as being heavier than aluminum, but that really doesn't make any sense. If you've got an iron nail, it is going to weigh a heck of a lot less than an aluminum airplane. So what we really mean is we mean iron is more dense than aluminum. If we had same amounts of them, equal volumes of them, the mass of the iron would be greater than the mass of the aluminum. And I did say that we would look at grams per cubic centimeter. We should just take a quick look. Remember, 1 kilogram equals 1,000 grams, and 1 cubic meter is 100. There's 100 centimeters in a meter, so this is 100 cubed centimeters. Okay, and that cube acts on everything in here. So this is 1,000 grams per a million. 1, 2, 3, 4, 5, 6 cubic centimeters. Okay, well, this is equals to 1 times 10 to the negative third grams per cubic centimeter. Okay? So a gram per cubic centimeter is 1,000 times smaller than a kilogram per cubic meter. And to put that in perspective, aluminum has a density of 2,700 kilograms per cubic meter, or 2.7 grams per cubic centimeter. We use this one a lot because grams and cubic centimeters are easy to measure for small samples. This is the official SI unit. Okay? So be able to go back and forth between those. It's just a matter of moving your decimal 3 places. Okay? Now, the last thing I want to talk about in this video is pressure. Pressure is a result of a force acting over an area. There is a caveat to that. We assume that the force is perpendicular to the surface on which it is acting. So if you think about a floor, something sitting on the floor, when something lays on the floor, it exerts a pressure on the floor, and that pressure is equal to the force down and the area over which it acts. If you had something on a ramp, it would still exert a pressure on the ramp, but the force would be not this component of force, but this component of force. It's actually perpendicular to the ramp. Okay? Not going to deal a lot with that, but do be aware that pressure is equal to force over area. Force, recall, is measured in newtons. Area, again, would be measured in square meters. Okay? So the unit of pressure is a newton per square meter. That actually does have a name. It's called a Pascal. Okay, this is named for Blaise Pascal, who did a lot of work with pressure and fluids, and we'll talk about him later. The abbreviation for a Pascal is a PA. Now remember, a Newton is actually not very much force. It's about a quarter pound of force. A square meter is a considerably large area. So 1 Pascal of pressure is very, very low pressure. If you took a quarter pound hamburger and spread it out over a square meter, that would be the pressure that a Pascal is. So a lot of times you'll see kPa, that's kilopascals, that's 1,000 pascals. There is another unit of pressure that you guys are probably familiar with, and that would be the PSI, pounds, which is force, per square inch, which is area. Okay, and a pound is fairly large, a square inch is fairly small, so a PSI is quite a bit bigger than a Pascal. Okay. That should be enough to get us started. You do have a few problems I want you to work on pressure and density, and then we'll actually start getting into the fun stuff where we can put in the fluids.